human colony on Mars? We live and work inside of here, the Mars Base 1, where our oxygen levels can be controlled. But sometimes I get to go out on the red planet and look around. As you know, Mars is the fourth planet out from the sun and is 49 million miles from our home planet Earth. We live and work inside of here, the Mars Base 1, where our oxygen levels can be controlled. Scientists say that after Venus, Mars is the planet most like Earth. We always used to wonder about Mars. Things like, did it ever contain life? Was it once covered with water, like Earth? So scientists years ago sent this very robotic lander to get some answers.
How can they hear you inside that spacesuit?
Okay, you got me. I'm not really standing on Mars. NASA isn't planning that mission for several years. But I am standing in front of a mock-up for a real Mars base at an exhibit sponsored by COSI.
Yeah, and it helps us learn more about Mars and the different probes we've sent there. Do you know the United States is not the only country to be curious about Mars? For the past 30 years, both the Russians and the United States have been sending probes to Mars. But this robot is actually a real Viking lander on loan from Martin Marietta, who designed the real thing. There are only 5 of these in the whole universe, and 2 are actually sitting on Mars right now.
The Viking mission to Mars is one of the most important in our space program. And this happened before Michael and I were even born.
Sounds like it's time for a space capsule.
Oh, no.
Duck, here it comes now.
Throughout the history of time, people long dreamed about the stars and the heavens. What was out there? How could they get there? Would they ever set foot on another planet? By 1975, NASA rockets had sent 12 spacecraft into space to give us our first close look at Mars. Our greatest achievement at the time was getting men to land on the moon. And Mars was 49 million miles away.
So we launched Viking 1 and 2, a pair of twin robotic landers, a month apart from one another. Across the vastness of space, they traveled for a year until they reached their destination. Retro rockets slowed their flight until they were in Martian gravity and achieved orbit. Viking 1 was headed to a plains region known as Chryse, and Viking 2 was to land in Utopia, both carrying the American flag to a new planet. Parachutes and retrofire were used to ensure a soft landing, but the spacecraft had to land on their feet and not fall over. If they landed upright, the world would have its first on-site look at another world. If they fell over, the mission would be lost.
Suddenly, a transmitted message was coming through. Computers clicked and buzzed. What would we see? Were the landers face down in the dirt? A mission lost? But there it was, a Mars horizon. We had done it. We were upright.
The first soft landing laboratories on another world fired back thousands of pictures and scientific data about the red planet. They even had incredible robotic testing laboratories inside and arms to reach out, scoop up, and bring aboard the Martian soil. They sent back 46,000 pictures, but there were no Martians waving at us.
Does that mean that there is no life on other planets? Who can really say what's out there? Unless we set out to discover new worlds. And now we're in the 90s, and we're really working hard to send another mission to Mars. Plans are to have a Mars base just like this one. Michael, let's go inside.
Good thing you two came inside. Our meteorology station reports a large dust storm approaching Mars Base 1.
Dust storm approaching in 30 seconds.
Chris, give me a status report.
The storm appears to be traveling at 120 miles per hour. Estimate 30 seconds to impact. Should we activate emergency launch procedures, Commander?
No time, we'll have to weather it. Hold on.
Activate emergency procedures. Activate emergency procedures.
Is this normal on Mars?
Sure is, especially during dust storm season. Let me help you off with your EVA suit, and then we'll check the ship for damages. Michael, go to the meteorology station and give us a status report.
Some storm.
On the rocky plains of Mars, there are many dust storms. Sometimes these storms can be so heavy that they measure 4,800 miles long and 2,500 miles wide. That's like a dust storm across the entire United States.
That planet looks pretty desolate.
Then you'd fit in just fine.
We don't know if it was always that way. Scientists think that water once flowed on the surface and carved deep channels, like the Valles Marineris Canyon system. This system covers 3,100 miles and is 5 miles deep. That's 10 times the size of our Grand Canyon. We also know that there are several huge volcanoes on Mars. The largest is Olympus Mons, which is 310 miles across and 15 miles tall. The diameter of its crater is 50 miles. But as far as we know, all the volcanoes on Mars appear to be dormant.
Hey, look over here. It appears that the soil is made up of the same common elements we know of on Earth. But it doesn't appear to contain any life.
Hey, look here.
Do you think there is life on Mars?
Yeah, like little green Martians with beady eyes.
Let's see what we do know from the Viking landers.
Try to answer these 8 questions about life on Mars. Do you think there is life on Mars?
The red planet is the only planet that has an atmosphere and temperature that is close to that on Earth, and like the Earth, it rotates on its axis every 24.62 hours. But could they be even more similar? Could Mars ever have contained life? We know that the surface temperature during the day has a high of 68 degrees Fahrenheit. That's pretty much like our own planet. But at night, the temperature dips to a low of minus 220 degrees Fahrenheit.
That's cold.
Unfortunately, after studying all of the soil samples obtained on their missions, the Viking landers could find no complex organisms that would give us the evidence of life.
So I guess there really is no life on Mars.
No life on Mars? Well, maybe not as we know it, but there are scientists who believe that water has collected within the cold rocks on Mars' surface, sort of like going way inside to keep warm. They feel that inside there are perhaps the same microorganisms and tiny plant life that grow right here on our own planet, in very cold places like Antarctica.
Well, I guess we're just gonna have to go see for ourselves.
You know, we do have several missions planned for the next decade.
I have a mission to Mars. That's in a couple years.
Dad, here comes another space capsule.
3, 2, 1, liftoff. And the Titan IV with its Mars spacecraft has cleared the tower.
In the late 1990s, NASA plans to launch a very special spacecraft to Mars. Its mission is to collect precious soil samples from the planet and return them to Earth. 2 Titan IV rockets will be launched, each carrying its own payload. When they finally arrive at Mars, each of the payloads will be released into an elliptical orbit around the planet. One of the payloads will contain the Mars rover and the Mars orbiter, along with an Earth return vehicle. The other payload will contain a Mars ascent vehicle and an imaging and communications orbiter. After controllers decide on the landing site, the communications orbiter will perform a burn to slow it down for entry, and the ascent vehicle will prepare to land on the Martian surface. The Mars rover is a really cool radio-controlled robotic car that will have its own artificial intelligence. It will allow controllers on Earth to see through its video cameras mounted on board. As it rolls along collecting soil samples, it will also be sending us digital video images. TV from Mars. Then, after gathering all of the soil samples we need, the rover will be told to rendezvous with the ascent vehicle that has been waiting. When it gets there, the rover will hand over all of its samples in a small canister. The ascent vehicle will then be told to rotate to a vertical launch position on its own built-in platform. Pretty handy, huh? Then the rover will go off to do some more scientific tests. Controllers on Earth will fire the ignition switch to launch the boost module from the platform. Wow, what a keen launch. And at a certain altitude, it will coordinate itself in the same orbit as the Mars orbiter, which has been orbiting the planet all that time waiting. They'll do some pretty sophisticated radar scanning to locate each other. There, they're connected to each other. Now this is the really neat part. Up in space, millions of miles away, they'll each do a series of burns to position themselves for docking and handoff. Once they're docked, a series of signals tells one to pass off the canister to the other inside the Earth return vehicle. Then the ascent vehicle is not needed any longer, so it undocks. The Earth return vehicle then will do a bunch of injection maneuvers, and the sun powers its 1-year trip back to Earth. The crew of the space station will send out an orbital maneuvering vehicle to get the samples. Long ride for some rocks. Then all that's left is to hop aboard a space shuttle for their long ride back to Earth.
In the meantime, it will be very important to get the space station Freedom in space. We will need a space station for refueling, like a sophisticated truck stop in space before astronauts take off for Mars, which is millions of miles away.
Wow, astronauts, scientists, and engineers are going to work inside a space station, just like this one, performing tests and experiments, and actually living in space all the time. Wouldn't that be great?
And once the space station is up, then an actual manned mission to Mars will be planned to land on the surface.
Someday we'll take a spaceship and head for the stars and travel about a year or so. Destination Mars. It may be solar powered or methane fuel. No matter how we get there, it's gonna be so cool. New space explorers, cool right to dudes. Carry all our dudes aboard and take along some food. Many nations from this earth will travel on this trip. We'll start a Martian colony all aboard this ship.
Geological excavations.
Going to Mars, going to Mars.
Major cosmic cool vacations.
Going to Mars, going to Mars.
Geological excavations.
Going to Mars, going to Mars.
Major cosmic cool vacations.
Going to Mars, going to Mars.
Any way you shake it, we'll have to build roads, survey rocky landscapes to carry our loads. Our sister ship will meet us and bring more supplies. We'll build lots of buildings so we can go inside. We're gonna colonize,
winterize,
realize,
improvise when we tackle
space, and for the human race.
Geological excavations.
Going to Mars, going to Mars.
Major cosmic cool vacations.
Going to Mars, going to Mars.
We don't know what we find when we colonize the town. There's work to do inside, but times we like to look around. When we get an itch to go, we'll hop up on a rover and take a little track around and look the planet over. The food won't last too long, so we have to grow our own. With modern scientific ways, we'll make it seem like home. Hydroponic veggies, beans that grow in dishes, genetic hybrid wheat, and tanks to raise our fishes.
Geological excavations.
Going to Mars, going to Mars.
Major cosmic cool vacations.
Going to Mars.
Whoa.
Going to Mars, going to Mars.
Hey, yeah.
Going to Mars, going to Mars.
All eyes on Earth will watch the colony grow. Without gravity to help, it will seem to move or slow. Through mineral extraction, we'll have fuel and heat. We'll be space explorers, it's gonna be a treat. There's Phoebus and Deimos, the Martian double moons. I can't believe we're going there, it's gonna be real soon. Kick back, chill out, and hang among the stars. Cause we're the space explorers living right on Mars.
Geological excavations.
Going to Mars, going to Mars.
Major cosmic cool vacations.
Going to Mars, going to Mars.
Geological excavations.
Going to Mars, going to Mars.
Major cosmic cool vacations.
Going to Mars, going to Mars.
Yeah, living right on Mars. Yeah, living right on Mars. Yeah.
I know this is all serious and everything, but some of those tests just look like a lot of fun. I mean, floating around weightless. Yikes, not again. Many of the tests are ones to see what happens to the body in weightless atmosphere. The low gravity of space causes muscles to atrophy and the bones to lose their minerals and become thinner. In order to survive a long ride to Mars, scientists need to know as much as possible. Back in 1973, we had a Skylab 3 mission in space that lasted 84 days. The Skylab astronauts had to work out daily to keep their muscles in shape for such a long time being weightless. Many scientists feel that before we even attempt to go to Mars, we'll need to do a long-duration space flight that lasts 600 days to see what would happen to the astronauts. Our studies in space have given us technological breakthroughs in so many areas that help Earth today with computers, weather, medicine, growing food. Every time the shuttle goes up, we learn valuable things that help us to advance.
Good job out there. Successful mission. Well done.
Bye, Commander.
Bye, Commander.
It's so cold there. You know, it's hard to imagine how anyone could really live on Mars.
You know, scientists have a new notion to take what we have learned from our mistakes and cause a greenhouse effect to occur on Mars. They think they could seed the atmosphere.
Seed it?
Yeah, on purpose, and create an atmosphere that would cause a planet to go through a global warming effect and bring up the temperatures to sustain life.
Who knows? Maybe they can make it work.
Can you imagine how those scientists will feel opening the canister and being the first to touch red Martian soil? But it's gonna happen before you know it. It's right on our fingertips.
What? Red Martian soil?
No, silly. The future. We'll be planning to go soon, and you just might be one of the first astronauts whose human footsteps are on Martian soil. The sophisticated data obtained from both Viking landers have given us a way to visualize what the planet might look like if we were to fly over it. A supercomputer at NASA's Jet Propulsion Laboratory in California took 37 days working round the clock to make 3,500 frames for this three-dimensional graphic computer simulation of the surface of Mars. Come on, let's fly!
Boy, was that cool or what? A computer figuring out for us what a place looks like before we even get there.
Well, the more we learn here on Earth, the more prepared we are when we go to Mars. Well, time for a spacewalk.
Hey, it's only an exhibit.
It's okay to pretend. Besides, maybe someday I'll really be an astronaut. See you on Mars.
Geological excavations.
Going to Mars, going to Mars.
Major cosmic cool vacation.
Going to Mars, going to Mars.
Geological excavations.
Going to Mars.
Scientists believe that 4.5 billion years ago, clouds of interstellar dust and gas pulled together under its own gravity. This spinning whirlpool produced a new star, our sun. Smaller whirlpools eventually formed planets. The young planets were continually bombarded by solid chunks of rock and metal ores, cratering the planets closest to the sun. Further from the sun, the cooler outer planets collected the remaining clouds, forming giant worlds of gas. Today, we know that 9 planets, many moons, asteroids, meteors, comets, and other objects orbit the sun. Their orbits are roughly circular or elliptical in shape. Each planet is roughly twice as far from the sun as its inner neighbor. They stretch more than 12 billion kilometers across space. This vast system depends on the gravitational attraction of the sun to maintain its delicate balance. The sun contains over 99% of the mass of the solar system. It is larger than 1 million Earths combined. The pressure of this enormous mass heats the core of the sun up to 15 million degrees Celsius. At these extreme temperatures, hydrogen is fused into helium. Energy from this fusion is the source of most of the heat, light, and other forms of energy that come from the sun. Fluid motions within the molten core of the sun turn it into a giant magnet. The magnetic field generated by the sun's core is called a magnetosphere. The magnetosphere reaches as far as the planets. Darker, cooler areas on the sun's surface, called sunspots, help scientists determine the sun's rotation. Because the outer part of the sun is a gas, the surface rotates at different speeds. 25 days at the equator, 2 days longer at the poles. Violent eruptions called prominences constantly explode from the sun's surface, sending up great sheets of solar material. Frequently near sunspots, streams of particles called solar flares rocket far out into space. A flow of ions and electrons, known as the solar wind, affects many phenomena throughout the solar system. The inner planets, Mercury, Venus, Earth, and Mars, are known as the terrestrial planets. All are relatively small and have surfaces that are rocky and hard. Mercury, closest to the sun, is hardly noticeable from Earth. Space probes, however, reveal a surface covered by ancient craters. Without air or water to wear away Mercury's features, the craters remain undisturbed. The range of temperatures on Mercury is more extreme than on any other planet in the solar system. Venus, the brightest planet as seen from Earth, is the second planet from the sun. Venus' brightness comes from the reflection of sunlight off a dense and cloudy atmosphere of sulfuric acid. This atmosphere creates a greenhouse effect, reflecting the planet's heat back toward its surface. Because of the greenhouse effect, Venus is hotter than Mercury. Radar scans probing beneath the planetary haze of Venus reveal a dry and dusty world. Computers have used these radar scans to create a false color map of the Venusian surface. The rotation of Venus is extremely slow. Each day and night on Venus lasts about 2/3 of an Earth year. Venus is one of only 2 planets to rotate in the reverse direction from all the other planets in the solar system. These differences become all the more remarkable when we compare Venus to its twin sister in the solar system, the Earth. Our planet, third from the sun, is a blue world, the only planet in the solar system covered by oceans of water. Like all planets with atmospheres, Earth has an ever-changing weather system, powered by energy from the sun. Earth's air and oceans, as well as its soil, are all uniquely rich in oxygen, a basic building block of life. Earth's fluid iron core produces its own magnetic field around the planet. This magnetosphere is stretched by the solar wind as charged particles from the sun sweep past Earth. Our atmosphere sometimes glows from this impact in a light show known in the northern hemisphere as the aurora borealis. The Earth shares its orbit around the sun with a moon. we know firsthand that the moon itself is an airless and waterless world. Craters scar the moon's surface. Temperatures range from 100 degrees Celsius at midday to minus 173 degrees Celsius at night. The Earth is 81 times more massive, but the moon still has a major influence on our environment. Every day throughout the world, the oceans rise, then fall, according to the position of the moon. Tides are caused by the gravitational attraction of the moon and the sun. When the moon passes exactly in front of the sun, a solar eclipse occurs, blotting out the sun's disk for several minutes at a time and turning day into night on Earth. During a total solar eclipse, scientists can observe the outer atmosphere and prominences of the sun. Mars is the fourth planet from the sun and only 1/3 the diameter of Earth. Its weak gravitational attraction means that Mars has a very thin atmosphere. Its windswept surface is dry and dusty and extremely cold even at the equator. Vast yellow dust storms often cover the planet completely, sometimes for months at a time. Of all the planets, Mars has an environment most similar to our own. The Martian day is only 1 hour longer than a day on Earth. And like the Earth, the tilt of Mars' rotation creates seasons. Since Mars takes nearly 2 years to orbit the sun, each season lasts almost 6 months. The surface of the polar ice caps, composed mostly of carbon dioxide, expand and shrink with the passing of these Martian seasons. Beneath the surface, though, a layer of water remains permanently frozen at sub-zero temperatures. 3 billion years ago, rivers of water flowed over the Martian landscape, carving out canyons similar to those on Earth. Gradually, this water may have evaporated or have been frozen, never to flow again. But the canyons are still there. One of them, Valles Marineris, stretches over 5,000 kilometers, more than the distance from New York to Los Angeles. Giant volcanoes once flooded the Martian terrain with lava. Olympus Mons, the largest volcano in the solar system, covers an area wider than the Hawaiian Islands. 2 moons, Phobos and Deimos, orbit Mars. Neither is more than 30 kilometers wide. Beyond Mars lies the asteroid belt, where an estimated 100,000 asteroids, more than a kilometer wide, orbit the sun. Some asteroids, however, orbit well inside the inner solar system. Most asteroids are made up of rock and metal ores, much like the composition of the planets. Beyond the asteroid belt is Jupiter, the first of the outer giant planets. Jupiter is more massive than all the other planets combined. Yet, like the sun, Jupiter is almost entirely made up of hydrogen and helium, the 2 lightest elements in the universe. Because Jupiter is gaseous, its atmosphere rotates at different speeds. Enormous energies help feed storm systems throughout the planet. The most famous, the giant red spot, is at least 300 years old and many times the size of Earth. Jupiter's intense magnetosphere is as wide as the sun, creating auroras throughout its atmosphere. A faint ring of tiny dust particles orbits Jupiter. The ring and Jupiter's 16 moons make Jupiter something of a solar system in its own right. The 4 largest moons are known as the Galilean moons, in honor of their discoverer, Galileo. Callisto, Ganymede, Europa, and Io. Most striking, perhaps, is Io. Io's constantly erupting volcanoes spew sulfurous gases and particles hundreds of kilometers into space. Saturn, the 6th planet from the sun, is smaller and colder than Jupiter. Saturn's rings are more famous and beautiful than any in the solar system. Close up, they reveal a series of ever finer ringlets, like the grooves of a phonograph record. Though less than 100 meters thick and composed of little more than chunks of ice, the spectacular rings spread for hundreds of thousands of kilometers into space. Divisions in the rings are thought to be caused by the gravitational attraction of some of Saturn's moons, which act as shepherding satellites. Saturn's largest moon is Titan. Titan is the only moon in the solar system known to have an atmosphere. Beyond Saturn lies the smaller world of Uranus, about 15 times the size of Earth. A green atmosphere rich in ammonia and methane covers Uranus, creating chemicals similar to pollutants found in smog. Uranus rotates almost completely on its side, and like Venus, its rotation is in the reverse direction from the rest of the planets. Stranger still is Uranus' magnetosphere. Instead of matching the axis of its rotation, like other planets, Uranus' magnetosphere is off-center and tilted 55 degrees. The daylight side of Uranus emits a shimmering ultraviolet light called electroglow. Scientists believe this electroglow is the cause of an extremely thin cloud of hydrogen gas extending far beyond Uranus' moons. 10 thin carbon rings orbit Uranus, as well as 14 moons. Miranda is the most remarkable of Uranus' moons. Enormous fault systems range over one side, while the other side remains relatively undisturbed. Neptune, from Earth, is a tiny featureless disk. But, like Uranus, Neptune may have undetected moons in addition to the two already known, and perhaps rings as well. Pluto is the smallest planet and furthest from the Sun. It is about the same size as our moon. Pluto's orbit is tilted from all the rest of the planets. For 20 out of every 248 years, Pluto passes inside rather than outside the orbit of Neptune. A single moon, Charon, orbits Pluto and is almost half its size. Pluto's rocky core is covered by water ice and frozen methane. It has a methane atmosphere. From Pluto, the sun would look like an intensely bright star. Comets, too, light up the night sky. They glow from their impact with the sun's radiation and the solar wind. Most comets originate outside Pluto's orbit and continue circling the solar system for centuries. Comets are often confused with meteors, the bright, quick streaks of light known as shooting stars. Every day, millions rain down upon Earth's atmosphere and melt away in seconds. Our solar system will endure for billions of years. Born in the same interstellar fires, the sun and planets, the moons, comets, asteroids, and meteors all share a common heritage. Yet each has evolved into its own unique world, different from all the rest. As far as we know, life exists on only one world in our solar system, a small blue planet called Earth. This shows how fragile the balance is between heat and cold, water, soil, and air. Let us learn then to care for this garden planet of ours, just as it cares and nourishes us.